All right, I believe. Good evening, everyone. I hope you are doing well. I hope you're enjoying the session so far. I hope the hackathon is enjoyable, and especially yesterday's session was really great. We learned about GitHub and Copilot and how you can use that in your hackathon. So today, as you can see on the screen, we're going to be talking about Azure and the cloud. And our speaker for today is Marjan Hussein. Marjan Hussein is currently working at Microsoft at the ADC ecosystems, and she's also an AI engineer. And so, without much ado, I'll let Marjan take the stage and talk to us about all things cloud and all things Azure. Welcome, Marjan. Stage is yours.
Thanks so much, Gregory. I had muted myself like the laptop, so I was like wondering why I'm not hearing you. But I guess you've introduced me. That is me, Marjan Hussein. I work at Microsoft ADC Ecosystems team. My primary work is focusing on the student developers in universities and even colleges. All right. So if you could stop sharing your screen, Greg. Thanks. So yeah, I was supposed to cover Azure for Cloud, any Azure services that you can use during a hackathon. I had the freedom to pick any, and I decided to pick Azure Machine Learning. So like I'll go through Azure Machine Learning, specifically the concept of deep learning, and then we'll do a small demo on how you can learn by yourself in the Azure Machine Learning Studio. Great. Okay, let me see what you guys are saying. Wait, is my screen up?
Yes, your screen is visible.
Okay. Wait, are you seeing the concept of deep learning, or are you seeing the teams?
No, we're seeing the concept of deep learning.
Okay, great.
We're
Because
seeing your whole PowerPoint screen.
oh yeah, awesome. That is what's supposed to be there. Okay. So let's go to the explanation of deep learning. So think of deep learning as a biology. I'm going to explain things in simple terms so that you understand. So let's think of deep learning in your brain as a biology concept. So deep learning is like a more advanced type of machine learning that mimics the way our human brain biologically works. So in our brain we have neurons, right? We all know that, and each neuron is connected to another neuron by a nerve extension. That is what we study in biology. And these neurons, they communicate to each other by passing electrochemical signals through the entire network. So like as you're imagining the network of the neurons in your brain, so when the first neuron in this network is triggered, for example, someone has pinched you or slapped you, so of course your neuron will be triggered. So the first neuron, when the first neuron is triggered, it's going to process an incoming signal. So if it's strong enough, there is a certain threshold like that has to be passed for it to acknowledge that the signal is strong enough. So when the signal like passes a certain threshold, it's going to activate and send signal to the next um, neuron that is connected to it. So these neurons, they also activate and pass the signal further through the entire network. So that is how the brain works. So as you continue to learn a specific action, the connections between these neurons, they become much stronger. Let me give an example with this. You can see when a ball is being thrown towards you. So of course, right now when I throw a ball towards you, you will catch it, right? But how did you learn it? the neurons help you to process that when you see a ball coming towards you, they coordinate the movement of your hands and you catch the ball. So the more you practice catching a ball, the stronger the neural connections become and the more you get better at it over time. So the same thing I'm trying to explain, deep learning, it tries to imitate the biological process using let me say artificial neural networks, and that is how it works. So instead of the electrochemical signals that I've explained in the human brain, it works with numbers. So in this artificial neural network, the connections, those signals that are incoming, they're represented by numerical inputs, not signals at this point. Now I'm talking about numerical inputs, and they're usually labeled as X. I'm sure you've encountered XWB when when you've passed through or skimmed through deep learning, or if you're good at deep learning, well and good. But so when these labeled inputs X, when we have multiple X, they are being treated as vectors now in the field of deep learning. So each input, that is
Hi, Marjan, I think we've lost you. Or is it just me on my side? Can someone else confirm if they can hear Marjan?
No, we lost her.
It's not you alone. Even from my end, I can't hear her.
Okay. Let me just reach out to her.
Me also, I'm not hearing anything. Kindly.
Hi, yeah, so Marjan is coming back shortly. She is experiencing a bit of network issues. So in the meantime, I never knew a tech session would start with a background in biology. Most of us I know didn't do biology in high school, but for those who did, I'm pretty sure this is something that is familiar with you and probably sparking something in your brain that you probably forgot. And I'm thinking the reason why she's chosen specifically machine learning is because machine learning and AI really is really key when it comes to coming up with most of the solutions that encompass persons with disabilities, or even in general, solutions that encompass people, right? If you're working with a people-centered solution, I feel like you should really try and scooch over to the side of AI and machine learning, simply because you're trying to come up with a solution that can also mimic human intelligence. And in this case, when you're talking about what's it called? Persons with disabilities. When you're talking about persons with disabilities, you're thinking about how they interact, not just with things, but also with people as well. So how can you make an interaction, let's say between a deaf person and yourself, as seamless and as human as possible, right? So first of all, you obviously know about the language barrier that is between a deaf person and you. Yes, both of you may understand English and can read English words if they are put in front of you, but you might need an interpreter when both of you are speaking, because if you're speaking to that person might not be able to hear you, and vice versa. When that person is speaking to you, you might not be able to interpret what he or she is saying. And these are cases where now we might bring about machine learning, artificial intelligence. And when it comes to such kinds of solutions, I've seen let me just give a small example and then I'll let Marjan continue because I can see she's back on the call. But the example I was giving is in Imagine Cup, there was a solution. Okay, there's one that came from Kenya, but the other ones I'm speaking about didn't come from Kenya. It came from another country. And in that solution, the participants came up with a Chrome extension for people who are deaf. And what this did is anytime you go to YouTube to watch a video, there is a person who appears down there and starts translating the video. So obviously, this is not a person who is hired to translate every video that someone is watching. This was achieved through artificial intelligence and machine learning. And I'm guessing that's why we are starting with a background on machine learning, artificial intelligence, deep learning, so that you can see how we can apply it, especially in Azure and in coming up with the solutions. So go ahead, Marjan, you can take it up from here.
Great, thank you. Sorry about that. I don't know what just happened to the internet. But also, I'm using my data, so I don't know anytime it might throw me out again. But I was explaining about bias and weight. Is that where we left off, I believe. But anyway, let's talk about what is weight in an activation function. So let's think of a good example of if you've done project management in your curriculum. Think of when you're a teacher or a teacher is marking an examinations, and then you have like different criteria of marking, or even judging a hackathon. There are different criteria of judging the hackathon. It might be creativity, it might be neatness, it might be accuracy. So, but accuracy is the most important, or let's say creativity. When it depends on not the cases, if it's judging, if it's marking. So the criteria that's most important, that is most important, that is where you give it the most weight. So weight and biasness, they're all used to control the accuracy of the deep learning model. Right. Okay, please don't stick there. All right. So this was I was trying to explain the emulation between X. Multiple X is considered as vectors, and there's weight and biasness. So weight controls the strength and the weakness of the output of the deep learning model, as well as bias. They control the accuracy of the output of the deep learning model. Okay, so the deep neural network concept is similar to the machine learning principles. So I have put here the concept of determining the penguins, what type of, is it a depending on the length of the penguin's bill, the depth, the length, and the penguin's weight. So as we are doing our demo, we're going to network model that calculates what type of a penguin this is. And I'll show you the good part of having Azure Machine Learning Studio in your project. So how do we use a deep learning model to build a classification model? So in my diagram, you can see this first row of x1, x2, x3. That is the input layer. Is Marjan breaking? Am I breaking? Is my network letting me down again?
Yes, you've been breaking, but currently can hear you clearly.
Oh God, I'm so sorry. I don't know what's happening to the network here.
It's fine. Now I can hear you clearly.
Okay, the first diagram, you can see x1, x2, x3. That is the input layer, and the blue part is the hidden layer, and the white part is the output layer. So the input layer, an input layer with a neuron for each expected input in the data set. The data set this so-called hidden layer connected layer. So they each contain 5 neurons, but you can tweak to the way you want depending on the level of accuracy that you want your deep neural network model to have. That is the middle part, that is the hidden layer. And then there is an output
Hi, Marjan, you're breaking
layer,
again.
the Y part, that is at for each class probability value that is MLP and FCN. So is more. Okay, what about now?
Okay, now it sounds better.
Okay, I think so. It's multi-layer is more of like a fully connected network. The basic concept here is like each neuron is connected to the other neuron. Look at the hidden layer. The first blue dark layer is connected to the fading blue layer. Each dark blue layer is connected to the fading blue layer. So it's like more of the same thing. So it's not different, but the multi-layer perceptron is a type of deep neural network model. But fully connected network is the name that covers, like the umbrella that covers the type of the models that we have in deep neural networks. Okay, so let me explain activation functions. I'm sure you've heard of activation functions. So there are two types of activation functions. This function and this rectified linear function. So the output in a sigmoid function ranges between 0 and 1, and it's oftenly used in the output layer of you've encountered the binary classification problems, right? That is why I use is mostly commonly used the sigmoid function. I'll explain, don't worry. And then for the rectified linear unit, it outputs 0, like if the input is a negative. So normally it outputs a positive value. And it's very popular in those hidden layers of deep networks because it's very simple and it's very efficient. So let me explain it in simple terms. I'm sure you're confused. So activation function, think of a neural network as like a series of decision making steps, right? So and every step it looks at some information and then it decides whether to pass into the next step depending on the strength of the strength of the information. Like I talked about the threshold. If it's strong, it passes. If it's not that strong, well, it holds it back. So why is activation function important in this equation? So um, if it wasn't there, the neural network will just be doing like, simple math, for example, addition, multiplication. But there are many problems in the real world, including a problem like recognizing an image in a photo, or for example, understanding spoken words. There are more complicated things than that. So we need a neural network model to do more than just simple mathematics. We need it to recognize patterns and make sense of the data that is fed into it. So like imagine like there's those switch. I don't know if you've interacted with a switch here, steamer. There's on and off parts. Okay, there's on and off parts. So if the neuron it gets very important information, the switch is going to flip on, right? That means it's going to send a signal. But if the information is not that important, it's going to switch it off, or it's going to stay quiet. And like I explained the sigmoid and the rectified linear function, I'm going to explain it in a simple way. So for a sigmoid, think of a soft switch. That switch that it's not on and off. There's a button, and you can just like slide it upwards, and then it can it can I don't know, it can like waka pole pole, and then there's inawaka kabisa, but just sliding pole pole. So I'm just trying to explain a sigmoid function as a soft switch. So like it doesn't just flip on and off like the normal switch. It can be partly on, like, or a partly off. So this is, it's important when we want to represent something in between, like a probability, between 0 and 1. There is 0 0.5, 0 0.7, 0 0.9. But for rectified linear unit, think of a simple switch, and on and off. Yes, like the volume control. Thank you so much, Greg. So, but for rectified linear unit, that is a switch, a common switch that is just on and off. So if the information is positive, the switch turns off. If it's negative, it stays off. So that is the difference between soft switch, the sigmoid, and rectified linear function. Okay, so let's go to training a deep neural network. So let me explain step by step. It's more of like training a machine learning, and I'm sure most of you have interacted with machine learning and have trained a machine learning from scratch, or have used transfer learning from a model that has already been built. But let's go step by step. First of all, you start with random values, right? And I'm going to explain it in simple terms, like using examples so that we understand. Let's have an example of a baby or a child. Say a child, and you're trying to teach your child to recognize animals. So, but for the first time, the child definitely doesn't have any idea of what any animal looks like, right? Because that's a child. So like you start by guessing randomly, and then you're like giving random animals. That is let's say you're giving weight and bias. Okay, but let me not go to weight and bias, that will confuse you. But that is the first step, data observation. And then the second step, now we are going to feed the data to our child. Now how do we feed it? We are showing the baby. Okay, why am I missing baby? Child, you're showing the child pictures of those different animals. Let's use cats and dogs. Those are the most common ones. And then we'll tell them this is a cat and this is a dog. We're feeding the data to the child. So, but this is known data. These are called labels. And what we're predicting is the feature. But this one is called labels. So, but you do them in batches, for deep neural network, you do them in batches, like you do in small groups. Those are mini batches, so that our child can understand it easier. And then let's go to making prediction. So now the child is now going to try to make the guesses when the child is being shown the picture. And then let's go to checking the accuracy. So after the child has guessed, you're going to tell them if they are right or wrong. And then, so the difference when the child's guess is wrong. When the child has guessed wrong and then there is a correct answer, so the difference between the child's guess and the correct answer is what we're calling it the loss in neural networks. So that's how you calculate loss in neural networks. Okay, let's go ahead. The next step is back propagation. Okay, so what's back propagation? Now the child was wrong, right? So they have to learn from their mistake. You tell them, hey, you said this is a dog, but it's supposed to be a cat. Just because a cat, sorry, just because it has floppy ears doesn't mean it's a cat. A cat has sharp ears, pointy ears. It's like you learn. The child has to learn and adjust. And then there's epoch repeats. So uh, you keep showing the child like more pictures, and then you adjust mm, based on the guesses that the child has made. So this process, it's going to like happen over and over again, and each round is called an epoch, so that the child learns. I hope you have understood the step of training a deep neural network model. All right, so let's go to what is batch processing and how it improves the uh, efficiency. Like I think I've just explained what is batch processing. So like it's easier for it's much faster for deep learning to process data in batches instead of just one piece of data at a time. So this, it's going to speed up the training process, thus improves efficiencies. Okay, let's go to matrices. Okay, processing observation as matrix. So when you're training a deep neural network, so when you process multiple pieces of data at the same time, you organize the data into like a matrix. So think of it as like a spreadsheet with rows and columns, and each row might represent, a picture, a piece of data, for example, a picture, and the column might represent the color of the pixel. So even the weight and the bias, the W and the X in the network are also organized in a similar grid-like structures. So when you multiply the data matrix, I hope I'm not being too technical. So when you're multiplying the data matrix by the weights and biases, then you can calculate the result of the entire batch of the data using linear algebra. So that is, I'm sure you have all learned about linear algebra. It's very important when you're learning deep learning. Okay, why are GPUs much faster? Why are they good for this? So GPUs are special hardwares, right? They were originally designed for, let's say, 3D graphics. Yeah. So because the GPUs are designed to handle those matrix operations. So in this case, it's going to be efficient for our case. They can process those batches of data like much faster than a CPU. So let's go to our next slide. Optimizers. Okay, optimizers. The neural network is like one big function that is made of smaller function. Okay, let me explain this slide in a simple way. So let's say you're blindfolded, you are told to shuka kwa mlima, like for example, you're standing on a hilly point and then you're told go down the hill, teremka chini. And then obviously as you're going down, like you can feel the slope on you're feeling the slope is going downwards. At least you know you're getting closer. You're moving in an upward direction, then you can try turn around and try another direction where you can random settings like random weights, random biases, like just random things. I'm moving too fast. Okay.
Hi, Marjan. We can't quite hear you. That is if you're speaking.
Okay, where should I go back? Drag my screen is visible, right?
You're breaking just a bit, so it's hard to get you. But I'm guessing, Glenn, you're being
Okay, someone
asked
type in
where.
this chat section if my screen is visible.
Yeah, screen is visible. You can see your screen.
And if I'm fast, okay, I think I'm back.
Okay. So, I'm seeing you're at optimizers. So you were being asked to start from optimizers.
Okay, okay, sure. Okay, let me start from optimizers. Okay, I hope before ipotee tena nitakuwa nimemaliza. Okay, so like optimizers. So think of when you're being blindfolded and then you're asked to go down a hill. So obviously, when you're going down a hill, you can feel the slope on your feet, and you can feel when you're going downwards. And you'll know you're getting closer to the lowest point. But if you feel like your feet is instead going upwards, of course you're going to turn around and try another direction that is going to take you towards the lowest point. So like it's like ulikuwa unatembea ukaona this is not the way, and then like you're turning direction, then you're like this is the right direction. It's like you're optimizing yourself for better results. But so let's go in neural networks. It starts with random assigning random values, the weight and bias. Like it's like being dropped somewhere randomly on that hill. You're being dropped somewhere random. And then let's think of an optimizer as a guidance. It's like it's helping you to figure out which direction to move in. So like uh, it will help you to decide whether you should change the direction or keep moving straight. So in this case, even in neural networks, um, the optimizers is going to guide the network to figure out which direction. So it's going to check the slope of the loss. That is the difference between the network prediction and the correct answers, and then decide whether to like increase or decrease the weight to reduce the loss. I hope you've understood up to there. So the optimizer doesn't just like just jump into conclusion. It goes step by step, like all the way to the lowest point that you are aiming to. So like it takes small steps, checking to and ensures that we're not just jumping to the next direction that we think it's right. And then we have two types of optimizers. There's stochastic gradient descent. This is like a very simple optimizer, and it takes small step in one direction that aims to decrease the loss, right? And then it goes like one small batch of data at a time. Like this one, it's like mpole. But there's this one famous optimizer that is called adaptive momentum estimation. It's like, yeah, however much it's very common and it's very commonly used, it's very advanced optimizer compared to SGD. And it combines two strategies. One, it keeps tracks of how fast you're moving. And then it adjusts depending on how big or small your steps are. It should be based on adaptive learning rate. That's why it's called adaptive momentum estimate. So it uses two techniques. One, it keeps track. Like the last time I used big steps, so like I should probably use a smaller step the next step I'm taking. So it is based on adaptive learning. Okay, so there is learning rate. So the learning rate is the rate at which the model is learning. So the size of the adjustment is controlled by a parameter that you set for the training called the learning rate. Yeah, you can also set this. These are parameters that you are setting, the learning rate, the optimizers. Those are all parameters that you're setting when you're training the model. Okay, let me go to the demo. Let me try and share my Azure portal. I hope you have subscription. Azure. If not, you can sign up for free Azure credits using your student email. Share my Azure Studio. Okay, it's not Studio. Azure portal. This is the Azure portal. I also about that. When you're a student ambassador, you're given a $150 that is renewed every month. Visual Studio's enterprise subscription. Okay, let me not waste any more time because my network was doing its own thing. So first things first, you sign into the Azure portal and then you create a resource. I've already done it so that in case, Greg, how many more minutes do I have so that I decide if I'm going to use the resource that I have?
The session's supposed to end at 8, so that would be 12 minutes. Yeah, but feel free to take your time whenever needed.
Okay. Okay, I'm going to try and see if I'll be able to do this demo. Okay, let's do it. Okay, if it takes a lot of time, I'm just going to the resource that I've already created, but I'm going to explain step by step on how you do it. So you click on create resource and then come to this search bar and search for machine learning. Machine learning. Let's go to Azure Machine Learning and create one. I hope it won't take a lot of time loading since my internet was giving me a hard time. Okay, so this is what we're going to do. We're going to create an Azure Machine Learning resource, but I'm going to skip that process because it's going to take a lot of time to do the deployment. So when you hit create, you have to like enter the values of each setting and then accept the remaining as default. So this visual enterprise subscription, this is the subscription for student ambassadors, or if you're a student, it will come there as a whichever subscription you've paid for. And there's a resource group. You can choose to have a default resource group or create a new one, and then you can enter a unique name and a region that is close to you, or sometimes for the region, let me tell you, when you're interacting with Azure and you're creating a resource for the region, sometimes it doesn't accept just any region. Sometimes you have to like research for if this resource is available in this region. You might go ahead and create a compute instance that is not available in a such region, and the deployment will fail. So when you're creating a resource, be careful on which region you're choosing. So I just chose, I think I chose West US, yeah. And then a storage account, you can create a new one if you don't have a default one. A key vault, you can also select the default one or create a new one. For the application inside, select the default one. Container registry, these are just the values that are randomly, it's like a configuration of the workspace that you're creating. And then you can review and create. So there's validation that has to pass, and then there's the deployment that has to run for some minutes, which I don't want to consume. And then after that, it has created our machine learning workspace. So let's open our workspace that I created some times ago. And then now we want to interact with the studio. So let me click this link. It's going to take me to the Azure Machine Learning Studio. Or if you can't find that link, you can just write https //ml.azure.com. Now this is our Azure Machine. Yeah, I also hope you've redeemed your your Azure credits. So welcome to the Azure Machine Learning Studio. It has a lot of interesting things you can use in the studio. Data, this Q&A on your data, use large language models and data from your own indexed files to ground around these verification. The prompt for the generative AI prompt. There's the models that you can use to use these models in your scripts. There's notebook samples. There's a lot of interesting things you can use in the studio. But let's stick to our plan. So we are now in the studio. What we're going to do is create a compute instance. A compute instance is like basically a virtual machine that is running in our studio. So let's try and see. I've already created my instance. Here it is. It stopped. Let me start it. I've already created it so that in case it fails, I'm on the brighter side. So let's see. Okay, this is how you create a compute instance. You come to manage, click, select compute, and then this pane appears. You see there's mine here that is starting. And then in this compute tab, you create a compute instance by clicking here, which I don't want to do it because I've already created one. And then there are values of each setting. There's configuration setting always in this type of things that you have to put it there. So there's the compute name that you have to enter a unique name. And then there's a virtual machine type. I recommend you choose CPU for now. And then there's virtual machine size. I recommend you click on standard DSS1 version 2. Yeah, this one. Click on this one. It's my recommendation though. You can go and research what these other things are doing. As you can see, the cost per each virtual machine size is $0.19. That's hourly usage. Monthly cost is $141. If you can afford that, well and good. Okay. So wow, my compute instance is running. I've named it Marjan compute instance, and it's running. So after you've clicked the create compute instance, it's going to start running, and then your compute instance is running now. Okay, now let's do the thing. Now come to authoring. If there's someone following along with me and I'm moving too fast, please let me know in the chat section. I'm happy to repeat. Just go to authoring notebooks. Sorry, I've clicked it. So I'm trying to remember what I did here, because when you click on the workspace that you've already created, you go to the authoring and you go to the notebooks, and then there are Jupyter notebooks that appears here. So you have to click on the select terminal that is there, and then how do I write this one here? There's okay, let me try and open a terminal, and then I type the GitHub command that is here. Is it this one? No, it's not this one. Let me just type here. Okay, so the first thing you have to do is change the directory. CD users. Okay, it's saying CD users because I'm already in the Marjan. Is it? I'm already in the users directory. Yeah, and then you have to type let me just finish this, and then you can screenshot my screen so that you get access to the notebook. Yeah, so clone this repository in your terminal, and then the file that I'm using here is published in Microsoft Docs/ML hyphen basics. The last part that I've written there, Microsoft Docs/ML basics. And then now in ML basics, there are these files that I love. There's first data exploration. Now here you can come and learn by yourself. That is the beauty of what I wanted to show you today. The first thing is exploring data with Python, and then you can and run these cells. It's explaining what the next cell is about. That is the good thing about Azure.
Hello, Marjan. You're breaking again. Can someone else confirm if they can hear her, or it's just me again?
Yeah, she's breaking.
Okay.
Okay, I'm back. Okay, hopefully this is the last time. This is the last time. It was working perfectly well. Now that I've joined this meeting, it's behaving this way. I don't know why. But I'm almost done with my session. Don't worry about my internet. Okay, we were in the notebook section of Azure Machine Learning Studio. Okay, 5 more minutes and then I'll be done.
I feel like if you guys have questions, you can just type it in the chat. And then once you're done with the session, you just do the questions and then we're done.
Yeah, Daisy. Hello. Am I audible?
Yes, we can hear you now.
Hello, am I back on?
Yes, you're back.
All right, I'm not going to take you to my studio. My notebook is there. It's going to take you to the chat, guys. Try and catch up with what I've taught you guys. Okay. So these are the click one of them. Teach yourself how to do these things. Run these notebooks. Learn the deep learning with TensorFlow. It's also about these models on the machine learning studio. So let me just drop there. If you have a question, feel free to ping me on my LinkedIn. Marjan Hussein, you can always read there. I'm always thinking about you've learned to you in your hackathons and have productive solutions. Back to you, Greg.
And I think we was taking over. Anyways, thank you so much, Marjan, for joining us. I think I will follow up on you on more resources that can use to learn about notebooks and machine learning. For me, my first interaction with Azure was the machine learning studio. We're training models of how to, we're training a model to detect cases of diabetes, heart disease, something like that. It was like 2 years ago. Yeah, but that was my first interaction with Azure Machine Learning Studio. So that is one way that you guys can use Azure in this project using the Machine Learning Studio. And I hope they're able to explore more notebooks there yeah, we understand about framework, it's something out of our control. But yes, if you can, maybe you can do like a recording of the demo that you are gonna do today, and then Greg and I can share it to everyone. Or alternatively, you can share materials with us, then we will share with our community members and hackathon participants. All in all, thank you so much, Marjan. I think guys will get to interact with you on your LinkedIn, and also the teams that will reach the finale will be coming to Microsoft. So she will be there, and you guys can reach out to her then. Other than that, I think I'd just like to say I've seen the work that you guys are doing, really commendable. Tomorrow we're having teaching, we're having I think a three times startup founder, he'll be teaching you guys how to create your pitch deck and everything. So yeah, so join in for the session tomorrow. If you have any questions, feel free to email Greg or me, and we will sort out any issues that you might have. Other than that, I mean, I feel like at this point I can just say a good night. Hope everyone is doing good. Yeah. Good night, everyone.
Thank you so much, Marjan, for the informative session. Good night, everyone.